So we spent the last two videos building up our Linky linked list library. So now what we are going to do is going to be simpler in comparison. I'm going to show you how you can use an existing library and reuse that library to create another library that extends its functionality. So concretely speaking, we have a linked list right now. Okay, so let's go to the whiteboard a little bit. We know how to implement a linked list. Well, what I would like to implement now is a stack. And the only thing that differentiates the stack from the linked list is that when I add an element to a stack, I'm going to always add to the front of the linked list representing the stack. So here I have a linked list with 3 elements. Okay, I'm going to use that data structure to represent a stack of numbers, a stack of integers, for example, 1, 2, 3. The only thing that's going to change is the policy for me to add an element is going to be using a function called push. And when I push onto the stack, I'm going to add at the front of the stack, for example. When I pop out of the stack, I'm going to remove from the front of the stack. Okay, so that's going to allow me to simulate the dynamic of a stack where you always, the last element that you add on top is always the one that goes out first. So you can only push elements and then pop the top element out. And I'm going to use my linked list implementation to do that because everything else, how I store the element, etc., is going to be exactly the same. So I don't need to rewrite this. And then we are going to use the same thing to implement a queue. And the difference with a queue will be that we are going to have two operations, enqueue and dequeue, okay? Add into a queue and remove from a queue, pretty much. And if I use the same example, 1, 2, 3, when I enqueue something, enqueue, I'm going to abbreviate it like that, that's going to correspond to adding at the front of the linked list. When I dequeue something, I'm going to pretty much do the equivalent of a pop, okay? But I'm going to do it at the end with the last element of the list. So the pop would be returning the value 1 and getting rid of this element. The dequeue will be returning the value 3 and getting rid of this element. So I'm building two new, I don't want to use the word API here for something that simple, but you know what I'm saying. I'm building here two new libraries on top of my linked list, and that allows me to save all the effort that I put into the implementation and the testing of the linked list to just provide different features, different data structure that behave slightly differently, but that at their core are all storing information using a linked list. So let's do that. Let's jump for the stack. So since I called my linked list Linky, I'm going to call my stack library Stacky. And hopefully we don't have to go too far from with this kind of silly naming. Pragma wants for stacky.h. And I'm going to include linky.h. Okay, I need it. I need everything in linky.h. The functions that I'm going to provide here, the prototype that I'm going to have, are going to be the push and the pop function. So for the push function, I'm going to call it node underscore push. It's going to take a node pointer and pointer called list. So I'm still following the same convention than for the previous work, okay? And then it's going to take a node pointer named element. So I'm still even keeping the same convention in naming the parameters for sake of consistency. And then I'm going to have the node pop function. The node pop function is going to return an int. It's going to return an int because at the core of all of my node data structures, I store a field named data that is of type int, okay? So I want to extract that data from the node, and I'm going to take as parameter a node ** list as well, okay? And that's it for my prototype. Now I'm going to go and implement those functions. So let's grab this. Let's go to a file named appropriately stacky.c. So this was stacky.h. Now we're looking at stacky.c, which is going to include stacky.h. Okay. And I'm going to provide the implementation for those two functions. So all of this is bookkeeping. Okay, all of this is cleaning up, organizing my code. Now for the interesting part. How do I write the push and the pop function? And the whole goal of this video is to show you how easy it is to reuse the Linky library in order to provide like a different library, okay? So not push. What is the operation of pushing? Well, we said that pushing is going to be adding as a front of the underlying linked list, right? So do I have a method to add to the front of a linked list? Of course I do. Node add front, and I will pass list, and I will pass element. So I totally delegate, okay? So all I did is I said that there is a special operation called pushing onto a stack, okay? If you want to use a linked list as a stack, then use only push and pop. If you use push, under the hood, what I'm going to do is I'm going to add to the front of the linked list, always. And that's it. So that's a one-liner. What about pop? Well, the pop function is going to be kind of similar, but there is one difference with what we've done before. So let me go over that difference first. You remember how we had the safety test here? If list equal null, return, and if, so it was like what? Star list equal null, I would return as well. The idea is if you give me, instead of giving me the address of a valid pointer to the head of a linked list, if you give me null, then I have nothing to do. If you give me actually a valid pointer, but that pointer doesn't point to a node, so the linked list is empty, then I return as well because I cannot pop anything. Well, we cannot simply return anymore. We cannot simply return anymore because this time our function is expected to return a value of type int. So I should return something here that means something went wrong, an error code of some sort. Since we haven't established, like a sentinel value of sort that could serve as an error code, what we are going to do instead, we are going to do something very, very, very rudimentary as far as handling error situation goes, okay? We are going to exit the application, okay? So printf error cannot pop from empty, from null pointer. There we go. Display that on the screen, and then exit, and the constant exit failure. And then the second one is going to be similar. If you ask me to pop from an empty list, I'm going to say cannot pop from empty stack. And then I'm going to exit with the code exit failure. Okay, so these are my safety checks pretty much. If I pass those safety checks successfully, then the rest of the work is not so bad. The rest of the work consists in saving the value that I want to return. So star list arrow data, okay? And then I want to remove the first element of my list, which I can do by just calling node del front, okay? And then when I'm done, return the value that I saved. So I saved the value that was in that first list, and then I deleted the first, in that first element of the list, sorry, in that first node. Then I deleted the node, but I let the function node del front do it. I didn't reinvent the wheel here. And then I return the value that I saved that way, okay? So again, you see how we have a little bit more work to do, okay? Because we return an int, we have to handle errors, and we do it really crudely here, but you would have to do it a little bit more seriously, right, in a real-world scenario. But the bottom line is that we wrap all of this new work that we have to do around using node del front. We are very careful to not duplicate any of the work that we've done already in node del front, okay? All right, let's save this. First, I've been typing too much without compiling, so let's make sure that we get rid of all of our compilation error. Okay, nothing, so far so good. Now we're going to test it. So to test, again, with that beautiful naming convention that I installed, it's going to be called stacky-test.c. So let's go. We're going to include stacky.h. All right. We're going to include stdio.h, stdlib.h. Okay. And we are going to have our int main. So we're going to do a lot of repeated operation, okay, to test. So I'm going to start with one, and then we're going to cut and paste a lot. So I need a node star my list. Let's try to be consistent in the convention for naming the variable here. Node star my list equal null to start off with. Okay. Then I'm going to display printf. Go to the next line. Initial stack, a tabulation, and then I'm going to display the content of that initial stack. Okay. How do I display the content of the initial stack? I call node display. Okay. I don't want to start with an empty stack. I'm going to start by creating node create, and I'm going to create a node that contains, for example, the data equal to the value 0. All right. So I use node create. I don't declare an intermediary variable n1, n2, n3, etc. I kind of make my code a little bit more compact here. I call node create. I put that as being the first node of my list. Then I'm going to say this is my initial stack. My initial stack contains node display of my list, and I need to pass the address of that. And that should tell me pretty much that I have a stack with element 0 in it. And that's it. All right, let's take a look. Let's compile again. Let's run it. And apparently I'm still running the old a.out from before. So I'm going, oh no, this is what I'm doing. I recompile the stuff I didn't need to compile. And so I might have still some how to say, syntax error. Let me get rid of linky-test and say that I want to compile instead stacky-test. I still want to compile linky and linky iterative. Let's pick iterative. We could pick recursive as well, no problem. And then I want to compile also stacky.c. I was not compiling it. No wonder that there was no problem. Fatal error, stack h, no such file or directory stack h. So I did an include of stack h instead of stacky.h. Here it is. Say fix that. Try again. All right, it's compiling. Let's run it. It's not displaying anything interesting. What did I forget? Stacky.test.c. Linky iterative stacky.c. Oh, that's odd. So let's do this. Printf should actually show at the very least. Okay, I should have a printf here that says, "Hey, I'm your initial stack." Let me take a quick look around, and I'll be right back. Okay, running a.out by typing rm.out. I was not paying attention to that part. Let's focus on the code. That's not going to work. So try again. A.out. There we go. Here's my initial stack. I'm going to add a printf at the end so that we have some spacing. Go to the next line before we display the prompt of the shell, and we will be all set. All right. So compile again, run again. And did I forget to save the file? Making a lot of silly errors in this video. That's nice. Let's compile this. There we go. And then, where am I? I'm on stacky, that's why. Up, stacky test, printf \n. Here we are. All right, let's clean up this screen a little bit. Let's do a.out. Here we are. Initial stack contains only the value 0. All right, we're good. Okay, so now what I'm going to do to continue testing, I'm going to push and pop things. So printf \n pushing, and I'm going to say pushing the value 1, a tabulation. And I'm going to say that I want to create a new node, and I'm going to pass it directly to my push method. So node push. I want to push on, and I'm going to be lazy, I'm going to cut and paste it. Probably going to save me a few typos, since I seem to be prolific in overlooking stuff here. So I want to push on my list, and what do I want to push? I want to push node create, and there we go. I want to create a node with the value 1. So I'm writing things a lot more compact than the previous video, but this is the same idea. And then after I'm done with this, I want to display my linked list, aka I want to display the content of my stack, the new content of my stack. Let's see how that works. Let's try to compile the right files for a change, and then a.out. So my initial stack contains 0. Then pushing means adding at the front of the linked list that is used to store the content of the stack. So the 1 gets pushed at the front. That's awesome. Now I'm going to do real quick a few more tests. Okay, so I'm going to take this, like so, and I'm going to cut and paste it a few times. So I'm going to be pushing the value 2, the value 3, and let's say the value 4. So here we are, pushing 2. You know what, this is ridiculous. I should really do a loop for this. So let's not be. There we go. So I'm going to do a little for loop real quick. For int n equal 1, and let's say equal to 4 and plus plus. That's going to be so much better. And I'm going to say I'm pushing the value of n, and I'm creating a node with the value of n here. So I'm pushing the value of n, I just put a %d here, and then the value of n, and when I create my node, I create my node with the value of n, and that should work just fine. Let's see. All right. So pushing so 0, 1, 2, 1, 0, 3, 2, 1, 0, 4, 3, 2, 1, 0. Perfect. We are pushing at the front. And now we are going to pop. Okay, so we're going to do the same thing. We're going to do again our little for loop. I think I can salvage, cannibalize most of this code. So here we are, popping. And I'm going to say that I'm popping. So I'm going to start by popping 4, then 3, then 2, then 1. So let's go reverse order here. 4, 3, 2, 1. And I don't need to create the node. I want to remove something from the stack now. I want to call pop instead of push. And because I'm calling pop, I need a value. So I'm going to say int value equal whatever I pop. Okay. And then I'm going to display my list, and we are going to see that the first value of the list actually disappeared. So the stack was popped. All right, save this. So we have the pushing, but I don't see the popping. Did I forget to save my file? No, I didn't forget to save my file. And minus minus. There we go. That was a wonky loop that was not even getting started. That's why. A.out. I'm forgetting something again. N equal 4 and greater equal to 1. That will work a lot better. Oh, there we go. So we push 1, we push 2, we push 3, we push 4, then we pop the 4, we pop the 3, we pop the 2, we pop the 1, and we are back to our initial stack that contained only 0. All right. So that's a good little piece of code there to just test out. Okay. And now we have our stack implementation, and it didn't take us that long. Okay. Without the narration, you could do that probably in 5 minutes, 2 minutes, I don't know. Probably 5 minutes, including the test, and that's it. So now what we are going to do, we are going to do the same thing, but we are going to do it for a queue data structure. So gedit, I'm going to edit new files. QE, just to continue with that naming, okay, which I regret now. QE.h, QE.c, and then test, QE-test.c. Okay, so these are the three files I want to use to implement my queue. And it's going to be very similar, okay? It's very, very, very similar. The same way that I had include pragma ones, etc. here. I'm going to, as a matter of fact, cut and paste what I have in stacky.h inside qe.h, okay? It's still including linky.h because I use it as a base pretty much for my implementation, okay? And the QE.h is going to feature the node, method, enqueue, and dequeue. And they work the same way, right? Enqueue is going to, actually enqueue is going to work exactly the same way. It's going to add an element to the top of the list, but dequeue, instead of working like pop and removing the last element that was added, is going to remove an element from the end of the linked list. So we enqueue an element and we always dequeue the element that has been for the longest time in the queue pretty much. Okay, that's how a queue works. So, but the functions are still very, very similar as you're going to see. So I have my QE.h taken care of. Let me get rid of stacky.h. What about stacky.c? Can I salvage stuff from there? Of course I can, or at least I can try. So I'll go to QE.c. And I'm going to paste what I had here. So instead of including stacky.h, I'm going to include QE.c. Instead of doing a push, I'm going to do a method function, enqueue. Instead of doing a pop, I'm going to do a function dequeue. How does the enqueue work? Well, exactly the same way. There's absolutely nothing there that I need to change. It's still adding to the front. So the pop, the push, and the add front, these functions are totally equivalent. But I have like different names so that I can restrict when I use a stack, I can restrict myself to use only push and pop. When I use a queue, I can restrict myself to use only enqueue and dequeue. Okay? So what about the other one? So the other one should be a little bit more interesting. How are we going to dequeue? Well, we are going to have the same kind of error, situation, processing, safety checks here. Okay? So instead of saying cannot pop, I'm going to say cannot dequeue from null pointer, cannot dequeue, from empty, and it's not a snack, it's snack. It's not a stack, it's a queue. All right, what else? So I'm going to need an int value. Okay, but this time it's not as easy. I need to iterate to the end of the list, save the value of the last node of the list in a variable like int value, for example, and then delete the last node of the list and return my value. So the return value, yeah, I'm okay with it. The node del front, no, that's going to be a node del tail of list. The value here, initially the value, I don't know what it is. So I'm going to put a 0 in it. And now I need to go and fetch it. So to go and fetch it, I'm going to have to use a loop. I'm not going to have to iterate. So I need a pointer. I need a temporary pointer on a node. I'm going to call that pointer P, just to be super original. And I'm going to say that that pointer P is equal to star list. So I made sure list is not null. I made sure star list is not null, so we're good, right? And then I'm going to enter my loop, my while loop. Here we are. And in my while loop, I'm going to say as long as there is a next. So as long as P arrow next is different than null, which I can abbreviate in P arrow next, okay, same condition, then I'm going to the next node. P equal P arrow next, okay? And then finally, when I reach the end here, then I can say value is going to be equal to P arrow data. So I'm going to declare value only here. I don't need to declare it, initialize it to some nonsense 0. I'm just going to declare it, and when I declare it, initialize it to p row data. So I locate the last node, and once I locate the last node, I read the data value from it. Once I have done all of this, then I can use node deltail to delete the last element of my linked list, which is the last element of the queue, right? And then return the value that I read like this. So that was super fast actually to implement both queue and dequeue. Okay, let's make sure they compile first. Let's make sure I compile the right file, of course, this time. So stacky test, no, we want QE test. Let's fix that first. QE test. I still want to compile linky.c, linky iterative.c. I could use linky recursive, and instead of stacky.c, I need qe.c. All right, let's compile this. No such file, QE test is because it's empty. Yeah, it's open in gedit, but it has not been saved to disk. So I'm just going to type something, save it. There we go. And then there we go. So now it's going to tell me you don't have a main. Well, it's because my QEtest.c is empty. So what I can do is I can, again, try to cannibalize what I've used in stackytest.c. Okay, so let's go ahead and modify what we have. QE. I'm going to create a node 0 initial stack. No, thank you. This is a queue. This is not a stack anymore. Initial queue is going to be the content of my list. Instead of pushing, I am going to be enqueuing values. And I do that by using node enqueue. Node display doesn't change. And instead of popping, I'm going to be dequeuing a value. So if I enqueue 1, goes to the front. Then 2 goes to the front, so it reads 2, 1, right? So the first one I'm going to dequeue is 1. So the order here between a stack and a queue changes. So I'm going to revert that loop to what it was before, 1 to 4, n++. This time I'm not forgetting to modify the n++ here as well. And this is how my dequeuing should work. So instead of calling node pop, node dequeue, node display, and we should be all right. So let's take a look. Let's save this, get rid of compilation errors first. Okay, none to speak of. Run a.out. Initial queue contains 0. Enqueuing a 1, it goes in the front. Enqueuing a 2, it goes in the front. All right, then a 3, then a 4, all of this goes in the front. Then dequeuing the 1. After dequeuing the 1 out of this list, unfortunately, we lose everything here. Okay, so that needs to be fixed. Dequeuing the 1 here, actually dequeuing should be 0. This is not what causes the problem, but they should still be fixed. I should dequeue 0 up to 4. Yeah, why not? Let's dequeue them all. Or actually 3 to be consistent with the testing. And I should call node dequeue my list and get that value out of the way and then not display my list. So we have a little problem here. So let me fix the number first. Start dequeuing 0 instead of 1 because 0 is the one that is at the end. And then we are going to debug a little bit what's going on here. So let me take a quick look and I'll be right back. All right, so here's what the problem was. If we use the recursive version first, it works, no problem. So there was a bug in the iterative version, which you can see on the left-hand side here of the screen. So now the iterative version is working as well. So if I compile and I run it, it's working just fine. The bug that we had here is I had to add, well, first I added this test here that I apparently completely left on the side. And then instead of using star list row next, then while star list row next, etc., instead of using star list everywhere in this code, I said I want a node star p equals star list. And it doesn't matter for this part of the code. I could continue using star list instead of p, but it matters for this part of the code because we set at some point p row next to null. So if we use star list and we keep incrementing star list through, we modify the pointer that was given to us by the main. That was a mistake. So I'm going to leave that on the screen. You can check it out, take a screenshot, and then go back modifying the code of our node delta in the linky iterative.c file. And then we're going to go back to our testing, which is the testing of QE.test. Okay. So we have a queuing of 1, queuing of 2, queuing of 3, 4. Queuing is adding at the front of the list. No problem. This is working. And then dequeuing. So we dequeue the element that was there the longest, okay, that was inserted first, that was 0, dequeue 0, dequeue 1, dequeue 2, dequeue 3, etc. And we have at the end a queue that contains only the element 4, which we could also dequeue. No problem there. All right. Okay. So I hope that despite the little bug that we tracked down, and I'm glad actually we tracked down to make an errata to the previous video, but despite this little bug, I hope you saw that it was very, very easy to take actually the code from Linky and adapt it to do something more with it, okay? And that's what you want to achieve with your code. You want to achieve a certain level of, a good level of reusability where you don't have to rewrite the same kind of logic over and over. Now that we have written the logic in Linky, and we even found a bug in it, when we were trying to expand, so now that we have used that library for QE, for Stacky, etc., now we have more confidence that it's correct, and we're going to keep using it, keep debugging it, and at the end of the day, the next time we need to implement a linked list, we'll know that we have a reliable implementation as opposed to have to rebuild the logic from start every time and take a chance to introduce a minor bug that's going to spoil your implementation and make you waste a lot of time. Okay? All right. So that's it for this illustration on how we could use Linky to expand it. If you have questions, again, you know the drill, office hours, Piazza, forum, whatever we use this semester, but I recommend really office hours. It's the best way to get somebody to help you run through an example that you find particularly difficult. And I will see you in the next video. Thank you for your attention.